Hai guys, dalam video kali ni kita nak buat sedikit revision tentang UPS 1 EP015. So jadi untuk UPS kita akan fokus kepada Course Learning Outcome CLO 1 iaitu Describe the Basic Concept of Mechanic Wave, Matters, Heat and Thermodynamic. Because of for UPS number 1, we just cover from topic number 1 until topic number 3. So, kita lebih kepada nak tengok anything that relate to the concept of mechanic. Okay. So, first chapter, Physical Quantities and Measurement. Yang berkaitan dengan describe, basic concept adalah learning outcome yang pertama, define dimension. So kita recall dulu what is dimension. You all boleh tengok dalam lecture note. This is the definition of the dimension. And then you all might be need to know a little bit about the 6 basic quantity. What is its dimension and how we write it. Macam mana kita tulis dan macam mana kita present all the dimension for basic quantities. So itu learning outcome yang you all kena cater yang mungkin keluar dalam UPS. The next learning outcome for chapter number 1 yang berkaitan dengan describe basic concept adalah definition. Definition for scalar, vectors, quantities. Kita recall. This is the definition for scalar and vector quantity. Soalan mungkin akan tanya what is scalar quantity, what is vector quantity based on its definition. Ataupun it can be asked you about some of the example. Adakah ia merujuk kepada scalar quantity ataupun adakah ianya merujuk kepada vector quantity. So very simple. Look at your learning outcome and then figure out apakah equation yang soalan yang mungkin keluar. So we move to chapter 2. Chapter 2, Kinematics of Linear Motion. The first learning outcome is about linear motion. Kita akan cater definition of the instantaneous velocity, average velocity, uniform velocity, instantaneous acceleration, average acceleration and uniform acceleration. So you all kena fahamlah setiap maksud tu, yang pemaksud dia, So then soalan yang mungkin juga keluar adalah interpret, sebab yang ni ada kaitan juga dengan basic concept, describe basic concept kan. So interpretation adalah salah satu soalan yang mungkin keluar. Macam mana tu interpretation? Interpretation, physical meaning of displacement, time, velocity time and acceleration time graph. Recall balik apa yang saya dah ajar you all dalam lecture hari tu. Saya ada buat sedikit summary for displacement time graph. Kita nak daripada gradient ni kita boleh dapatkan nilai velocity. Daripada graph VT graph kita boleh tengok dia punya gradient and then kita akan dapat dia punya acceleration. Kalau kita patah balik, so this one by using area under the graph kita boleh dapat dia punya velocity based on the graph V against T. Area under the graph kita boleh dapat dia punya nilai displacement ataupun dia punya distance. Remember that for the vector quantity kita akan include negative sign, but for scalar quantity kita ignore the negative sign. That's for chapter 2, subtopic 2.1. Kita move kepada subtopic 2.3. 2.2 dia apply kalau tak silap saya. So, dia tak ada kaitan dengan UPS 1 lah. Sebab dia bukan describe. Basic concept. Dia apply. So, jadi kita terus kepada subtopic 2.3, projectile motion. This one, describe projectile motion. Launch at angle theta as well as special cases when theta is equal to 0. What do you need to know? Just ingat yang ini sahaja. Kita seperti mana kita maklum bahawa projectile motion dia ada banyak-banyak jenis kan. Saya dah tunjuk dalam lecture hari tu contoh-contoh dia. Saya concludekan based on this diagram. I'll already tell you about the motion and then the sign. Cuma dalam kuliah hari tu saya tak masukkan ini. So kali ni saya masukkanlah benda-benda penting. Kalau kita buat based on the equation, so kita akan figure out that Vx equal to Ux. Horizontal component velocity sama dengan initial component, initial horizontal component of its velocity. And then because of projectile motion, free fall, semua tu ada influence of gravity. So jadi acceleration on the x component is equal to 0. Kita hanya ada acceleration on the y component which is equal to, kena ada negative. Negative 9.81. Kenapa negative? Because acceleration due to gravity is always acted towards to the center of the earth, which is downward lah daripada position kita dekat atas bumi. So dia akan jadi negative 9.81 ms minus 1. So along the motion, dekat mana-mana pun dekat dalam gambar rajah ni, any point here dia akan feel AY which is downward. Dekat mana-mana pun. Along the journey, AY dia punya acceleration is negative 9.81 81. And then dia punya kat mana-mana point, dekat point ni horizontal component velocity dia sama dengan initial component of its velocity. And then the sign of velocity. Okay, the sign of the velocity, if going up, kita akan guna positive. Going down, kita akan guna negative. As y is above the release point, kita akan guna sign positive. As y is below, if below the release point, kita akan guna negative sign. Okay. Next, we move to chapter 3. Dynamics of linear motion. Okay, di mana yang berkaitan dengan CO1, describe basic concept adalah definition of momentum and impulse. Okay, so kita recall dulu what is momentum. You all kena tahulah momentum is mass multiplied with velocity. And then it is a vector quantity. Sama juga dengan impulse. Impulse is a vector quantity which is represented by the equation F delta T. Okay, force darab dengan change of time taken. Ataupun kita ada lagi satu formula which is impulse momentum theorem. Okay, which is said that it's equals to the change of momentum, sama juga dengan mv minus with mu. So you all kena faham the definition of the momentum and impulse apa dia, dan juga formula yang kita mungkin akan gunalah untuk menyelesaikan masalah. Okay, just tahu formula. Subtopik 3.2, conservation of linear momentum. Okay, yang berkaitan dengan describe basic concept yang berkaitan dengan CO1 adalah state the principle of conservation of linear momentum. Okay, which is said that the total momentum initial equals to total momentum final. Okay. And then the next one, differentiate elastic and inelastic collision. So how to differentiate it? Kita akan tengok daripada kinetic energy. If both of the kinetic energy is equal, so jadi dia adalah pelanggaran kenyal ataupun kita panggil sebagai elastic collision. If there is unequal, tidak sama, total kinetic initial tak sama dengan total kinetic energy final. So jadi itu adalah pelanggaran tidak kenyal, inelastic collision. Okay, yang tu you all kena faham perbezaan dia. Okay. The next one, subtopic 3.3, basic of forces and free body diagram. Okay, identify the force acting on a body in different situation. So, jadi yang ini yang you all kena fokus. You all kena tahu macam mana nak identify the forces. Okay, so very simple guys. Yang ni memang nak kena guna sepanjang semester 1 dan juga semester 2. Basic force ni you all kena ingatlah. Okay, for the weight, setiap objek mesti ada weight. For tension force pula, kalau ada string mesti ada tension. Kalau normal force pula, pastikan ada contact surface, mesti ada normal force. Kalau friction pula, kalau ada rough surface, mesti ada friction. Ataupun apa-apa kenyataan statement yang berkaitan dengan rough surface lah. External force means that kita ada pull or push. Okay, and then for each of that, you all kena remember how to draw the free body diagram. For example, untuk string, the direction of the tension must be always outward from the body and along the string. Okay, last subtopic kita 3.4, Newton's law of motion. You need to state Newton's law of motion. Okay, very simple. Kita ada 3 Newton's law. Newton's law of motion yang pertama, okay, di mana kita menggunakan submission force equal to 0 untuk static and dynamic equilibrium. So, means that you all kena faham lah apa dia static equilibrium ni, apa dia dynamic equilibrium ni. Okay, kena ingat tau. Okay, the next one is the Newton's second law of motion, which is submission force equals to ma, yang biasa kita guna dalam equation untuk solve the problems related to the force, which come from the equation rate of change of momentum. So, terhasil lah equation F equals to ma. And then the Newton's third law is about action and reaction force, di mana every action has reaction force but acting in opposite direction, tapi nilai dia sama kedua-dua ni. Alright guys, itu sahaja. Thank you very much. Good luck.